I am doing it. I am doing it. I am doing overlapped I/O, and I am utterly confident that my voice is coming through on this recording, and that the system is not hung just because I'm reading a file, as it hung only a few hours ago when I tried to open this file in MS-DEV and managed to log off and log on as another user just to stop this process, because it couldn't be done here. Why? Because the bus was locked. There was no possibility to get for any devices to communicate with each other. The keyboard device managed to get me out, and out of this session and into a different session, which I don't know how, but I guess at that point the bus is free, because once I signed on to, it took a long time, but once I signed on to the other user, it had to play a sound. Once I heard the sound, I knew the process must have stopped. I tried to kill it. I still have the video of me trying to kill it. Well, it's not much to see. Anyway, let's see if this works. Now, what you just saw, not this, the little clip that I hope I have prepended to the head of this video. This, by the way, is a really great band. I'll post this link with this video. Can't post it on YouTube, blocked by the BBC Corporation. I guess the reason being that probably most of the executives there have investments in a lot of in these media companies, and since they can control what people see, they can earn more money that way. So they're protecting their investment at the cost of the bands, of course, aren't getting the exposure that they could get if they were allowed, if their performances were allowed to be shown. But you can see it on Facebook. Nobody's complaining. Now, that's a bit of a rant, but really you should watch this. Now, that thing that you saw, I said, I'm doing overlapped I/O, right? What happened, I've been trying to make this video, I don't even know, this one probably will be another miss, but I'll try anyway. I've been trying to, I'm not sure what the point is I want to make. It has to do with this optimization stuff, and the things the method that I discovered for creating or using what I named, because I've never seen the implementation before, a compression cache, which is sort of the opposite of usually of what people think, at least when it comes to a cache, right? A cache is not a thing that one associates with compression, right? A cache is a duplicate copy, right? Usually of something, but this is a kind of cache where eliminating duplicates, but at the same time making things, the things that have been most recently used, more quickly available. So that's a cache as well. That's what a cache does. One way to do it is to duplicate data, and one way to do it, apparently, is to remove duplication. As odd as it may seem, now the reason I showed you that thing with the overlap result was the last time my last go at this video. I mentioned again about that file. That was what started me on this road of trying to optimize my XML class. And I had said prior to that I was certain that it would open up in MSDev, right? Or at least in the binary editor. So, well, I wanted to make a quick edit to that file, right? Because I wanted to test that theory. So I tried, I didn't use my editor, just because I probably didn't trust it or something, or I thought it would be easier to just open it up where I was staring. And I just opened, using the file open thing failed. It said, the operation did not succeed or something. And then when I tried the binary editor and the text editor in MSDev, and that also failed to open it. Now, this was before I recorded the video, and then my last attempt at this video, I went to go and demonstrate that, and obviously this program doesn't use overlapped I/O either, and the bus got over busy, I guess, right? Like stalled or whatever, just hung. Like none of the hardware was responsive. So I couldn't, I couldn't press anything hardly at all. I did manage to bring this up, right? And I tried to kill MSDev. I tried typing that, nothing came out until about a minute later. And then I managed to click this thing, and I tried it there, and all the while the recorder was still going, but it didn't record any of that activity. I managed to log off. Log on as a different user on this machine, and just that act of doing that killed the process, because I suppose there must be when you log off, right? I believe that that starts up a new virtual machine, right? When you go and log on as a different user, with this user still logged on, then there are two virtual machines running, whereas here it seems like there's only one, because if everything was jammed, okay, at least for the operating system, there's one operating system running here on this for my user, and there must be one for another user. And although each process is is a virtual machine. They're all communicating with the operating system, and I think there's only one instance of that for one logon session. And so in that way, you can get like really jammed. So the video was ruined, and then actually I can show you I think I still have it in my garbage pail. I managed to do that. I came back on as this user. Do I still have it? This one. It's 10 minutes, yeah. Oh, yeah. Is that right? Yeah, I just overwritten something. Oh, no, it was boring. Let's click mute. I said, I came back and I said, so there you go. You see, MS Dev couldn't open it either. And worse than that, the system hung, and there was no communication between the devices, and I just managed to click the log off button, and once I got out and logged on as a different user, I was able to terminate that process. Otherwise it was jammed and the system was jammed. So then I said, just as a final demonstration, because now, if you remember before I said that my little hex edit thing was the only program that I'd written that could open that file. Well, now it's the only program I know of that can open that file. So I thought I'd just give a little demo of that. See? And I'm just curious to see how long it takes. Because it seems, well, with the recorder running, it's slow. Right? This recorder also is not using overlapped I/O, and I'm certain of that. And I'm going to show you that, why I'm certain of that in a second. Like the part that I showed you before. See, this is taking a long time. You must have noticed that it was slowing down as it was reading. Well, that's just my fault. That was because instead of doing the right thing of pre-allocating the size buffer I needed, I was calling reallocate over and over again. There's no point in having any audio on this card anyway. In fact, I can turn this on and there's no audio to hear. Because I know that during this synchronous read, the bus is busy, and so therefore the audio device can't receive any data because it shares the same bus. Video can, like I said before, because that video uses direct memory access, something called direct memory access. So it has its own bus, pretty much. That's why video cards always have a special slot on your machine, right? In the old days, you used to be able to plug them in anywhere. Well, but then in the old days, there was direct access too. I'm not sure about that. But when they came up with the Super VGA, I think it was, then they had to have a special slot for video cards because the number of data lines is larger than the regular bus. think the regular bus was 16 and the video cards were maybe 32 or something, or more. You see, this is taking a long time. It will come up. It is faster without the recorder, but still. And the reason is, the recorder is busy trying to write data to the disk, and this thing is trying to do the same, and so but it's worse than twice as slow. Notice how this stupid file, the last line happens to be 16, end up on a 16-byte boundary. Anyway, now I haven't fixed this program, but I'm going to run that overlap IO thing again. What I did, just as a quick hack, to avoid the realloc, was I just made I invented smart pointer of buffer is H buffer, and then I realized, well, I would still have to realloc it, so I just made a list of them. But then I got to pass the list back, and I don't want to, have to copy all those buffers. So I made smart pointer to list of buffers, and so therefore the only copying that's going on is just from the file, a great huge file, into a list of buffers, and everything else is just reference counting. So now it's quite a bit faster. It should be, and I shouldn't lose my voice or anything. See, it's not slowing down. It's the same file that when I tried opening this with my hex editor thing, it jammed the bus and I lost a whole minute worth of audio. I don't believe I'm losing any audio right now. Shouldn't be. The reason it's pausing is because it has to wait. The audio device is using the bus, and the more I talk, the slower it goes. That's the way it's supposed to work. It's cooperating. Okay. So now we're here, and it's definitely the file that I typed something in. Alan Carr was here to prove that I could edit it. Right? That's the size and the first 512 bytes of that. And it's all allocated, but not contiguous. But that's an easy fix. All I have to do is, instead of making a list, just resize my buffer to the file's size, and then this buffer class has an overlay function. So I read in some bytes into a smaller buffer, and that can be overlaid on top of the larger buffer, and that leaves me with one buffer which is continuous and contiguous, which I can use in my hex edit. And that, as you saw, only took a few seconds, right? I'm supposed to press any key to continue. It didn't take long. It didn't take nearly as long for that to occur with the. Will I press the any key? It does take a while to free all the data. No, but now see, I hope I'm not losing my voice now. I may have. I don't know if what I just said came out. I might have to cut this off and make another one. But let me go on for a little bit. I'll give you a preview of what's coming. I got to think of a way to present this very interesting strategy, this XML view thing. Right? I want to get these switches working. It's using that funny cache thing. I made a release version of it. Let me just show you with a recorder running. Opening this file, which is 7 megs instead of 700 or 800 megs, like the other one. So this is like about a tenth of the size. And this has the recorder running. And you remember that I told you not to trust me. That originally for this size file, I couldn't open it because I ran out of memory. Okay, and then I got it working so that I could open this file. It was still quite slow, and now I found another optimization, very simple optimization, and added that to this build. Now I'll just run this. Here it goes. The X's actually are not the same, they don't have the same meaning as before. The X's have to do with my new optimization. I have a database, and every once in a while the database basically gets sorted or balancing. See, it's already done that for you. Now it's just building the tree for the Windows control. This has 200,000 nodes, right? I have estimated from that that since the other one's sorry, not a tenth. This isn't a tenth of the size. This is 100th size, right? Of the other one. So the other one is going to have something like 20 million nodes. And I can show you the memory use just for this. Yeah, where are we? It's gone down. I got rid of. I did something, and I had explained it in a different video. I had a linked list of all the nodes because I had a memory leak, and I wasn't freeing the nodes. The easiest way was to just add them all to a list, right, and then free them. But that list, okay, I did this computation somewhere in here. You can see it's stuck at it's not going over 30. Where is that? Oh yeah, that just that list to keep track of the nodes so I could delete them for the other database would cost 600 megs. Okay, when in fact all I need is the head node is enough, right? So there's no chance that I'm going to want that list. But there's still no chance that I'm going to be able to open up that other database because it's got 20 million nodes about, let's say, and now all the memory is being used just for the nodes, and the nodes are too big. In fact, I counted it up, and it's about 30 bytes each. So 20 million, right, times 10 is 100 million times 300 megs just for the nodes, right? Well, the strings don't count for very much. Maybe it could, no, actually, 300? Good try. This takes a long time because of the printing. It shouldn't be very slow, I think, if I didn't do this. But I like watching this thing go through its little dance. Now, one of the things, too, that I realized is that at the end of if you manage to get to the point where the list is, the map is completely loaded into memory, then as these things are being added to the Windows control, they can be discarded from the XML control, right? But I can't wait to have them both loaded up before throwing away the other. If I could find a way to have them, to destroy the nodes immediately following adding them, I guess just destroy them, right? Then I could, I think it shouldn't grow anymore. It doesn't seem to be growing very much, though. Where is it now? 42. And from 30 to 42. Doesn't seem to cost very much to put them in the Windows thing. Probably because that doesn't go in my heap. Maybe. Right? It's maybe it goes in system memory or something. Why isn't it? Why aren't we up to 60? I'm not sure. But you saw how quick that was, right? But here's those, I can show you very quickly. We're going. The super duper extra optimization has to do with this data database, right? As the database grows, just like the problem I had with that I/O thing right now, these lookups become slower. Lookups in here become slower because it's bigger, right? And I don't want that. So every now and again, this macro is a thing that fires, if you like, every time you pass by, every time you look at it. Not every time you look at it. Every time you look at it, a counter goes up, and it fires when the counter reaches a certain amount, like that once every for time, but it's not time, it's occurrences. And it starts off at 1,000 for a while, and eventually becomes 1% of the database size. So now this is actually in the wrong place. It should be up here. Just fix that. Because after the database is loaded, you're still using it, right? And the way this thing works is these entries have derived from a special class called a touchy. And a touchy can be touched, and every time you touch a touchy, its reference count goes up. If not reference count, its touch count goes up. It's not a reference count. Reference count is a thing that goes up and down, right? This is a count that only goes up. So every once in a while, I sort the database, and the sorting is with respect to the count. The ones that are more active get pushed to the front of the database, and the ones that are hardly ever used go to the end. And so that's a tremendous speed increase. Now this sorting, right? This is the C++ thing that I wanted to mention because I'm thinking about the STL, and maybe I should leave it for the next video. This is something that everyone, I'm sure, would love to have, but it wouldn't work with the STL list. You couldn't do this with the STL list because if you do what I've done with an STL list, I'm pretty sure anyway, and that is I'm handing out to the nodes their positions in the list, right? Now, if I do a sort, you would think their positions change, right? But I don't do that kind of sort. I do an in-place sort. And I know that the STL is not doing that because I don't know if you saw, but there's a video on here somewhere where I compared the standard templates list class sort with my sort, and whereas their thing took something like 3 minutes, this thing took something like 300 milliseconds or something like that. A huge difference, you know, more than 10,000 times faster. And the reason it's so fast is because this sort doesn't move anything around. All it does is change the directions of the arrows. You know, I have another function called randomize that would also have no effect on these position pointers, right? Because it does the same thing. It just makes the arrow, the next and previous arrows change, but the positions of a given piece of data are fixed. They never move. And you wouldn't be able to do this with the STL list either because you don't have access to the internal pointers things. That's not exposed. There's a thing called an iterator, and it's all C++y, and you know, it's all kind of meant to be cute and look like you're counting up through integers or whatever. You know, all the complexities hidden, nothing exposed, and so there's no access to anything, and so you can't have this extremely effective optimization, right? Not only has it cut the memory down to nothing, but where is my program? Did I quit it? I'm still doing that. Let's see if it's grown in size. Not much. The memory's gone down to nothing. It's, you know, lightning fast. And now that I've figured out how to do this overlapped I/O, I'm not going to use anything else but overlapped I/O from now on. I can read in that database much more quickly, as you saw, right? That was the same, that thing that you saw where I was printing stuff out with the same read that was taking 3 or 4 minutes as a single call to fread, right? Blocking call. And I don't know why it's faster. Probably it's faster because there are communication problems, right? If the bus is jammed, if you're trying to transfer some data from one point to another, right? That's not a unidirectional thing. Like this side, where the receiver every now and again has got to tell the sender, okay, yeah, I got that last packet, right? But it's going so fast that it's getting it. You can get into a state, and that's probably the state that happened with this thing. The bus got locked, where the receiver can't tell the sender that it's received anything, because the unit itself is in a deadlock state. Actually, I mentioned that in another tutorial quite a long time ago, that that was one of the difficulties with our store software, where we were using bidirectional name pipes for communication, and there was this one store system that was their system. We're trying to draw a little 20 by 10, 20 by 2 by 20 screen of cash register screen, and that comes over the picture, screen, whatever, comes over a name pipe, and instead of just sending it once, it just keeps sending it continuously, right? And the name pipe communication got blocked. Would get blocked, and there's nothing you could do except reboot the machines. And that was when I suggested the ridiculous idea of increasing the buffer size of the name pipe to, well, why don't we just put it at 2 megs or something, I said. And they were all laughing, and I secretly went and just did that, right? And it worked, and nobody knew I did it, and everybody was happy. They thought the idea was like ludicrous. Name pipe. 1K should be enough, Well, it doesn't work with 1K. Well, why don't we put it at 2 megs, and we're sure we won't have a problem. But anyway, I'll show you more about how this works. Maybe I can turn this into a nice reusable thing. See you.